So in the last videos, I think we are discussing about binary search tree, and in the deletion there is some issue is there. I will rectify that issue in the tomorrow's session, and even the continuation of this AVL tree. So sorting and searching algorithms summary sheet and priority queue. These two things I am going to cover in the tomorrow's session. So today a small topic like what is mean by graph data structure. Let me complete this. Sir, generally, what is the definition of graph? Means a graph is non-linear data structure. It is not linear, sir. It is non-linear. Means what? So that consists of the following two components will be there. Sir, what are those two components? Is so a finite set of vertices. So also called as in our general terminology, it is called as nodes, and it is having a finite set of edges. So in the form of u comma v, in this style edge will be there. So where u and v are two vertices in the graph. That means what? Graph means what? It is nothing but non-linear data structure where, sir, you are going to have two components will be there. Okay. One is nothing but vertices, another one is nothing but edge. If you want, let us take one simple example. Sir, I am going to have three vertices are there like this. I want to connect these three vertices. So there is a connection between these two, and there is a connection between these two, and there is a connection between these two. It is called as a graph. So this is called as a vertex. Let us label this vertex as A, and this is another vertex called it as a B, and this is another vertex called as C. Like this, it is a combination of how many vertices? Three vertices. And if you observe here, there are some edges also there. So A to B, this is one edge, A to C, one edge, B to D, one edge. Like that, we are going to have. Okay, so A comma B is nothing but one edge. A comma C is another edge. B comma C is another edge. Where A, B and C are nothing but vertices what we have. So collection of these edges and vertices is always considered as a graph data structure. Of course, it is also similar to like a tree, but in the tree cycles won't be there, but in graph cycles will be there. Cycles in the sense loops will be there. If you take a tree, in that connections won't be there, right? It won't form a loop. But in the case of graph, it is going to form a loop. This is nothing but two important components where every graph is going to contain. Now, sir, there are different words are there to define the graph, but generally we will use two words. One is nothing but a directed graph. Sir, what is mean by directed graph? So a graph with directions is called as directed graph. Is called as what? Directed graph. That means so there will be a direction, and undirected graph is there. What is mean by this undirected graph? Sir, it is nothing but a graph without directions. That means directions won't be there. Such a type of graph is called as what? Undirected graph. In the case of undirected graph, in both directions we can able to move. Suppose if you want to take one example, suppose consider I have three vertices are there like A, B and then C. From A to B we can move, and from B to C we can move, and from C to A we can move. This is called as directed graph where there is a direction. And if you are representing the same graph like this, so A to B to C, A to C, then it is called as undirected graph. Sir, in the case of undirected graph, there are two possibilities are there. You can move from A to B and even you can move from B to A also. Okay, so both directions are allowed. But in the case of directed graph, any one direction will be there. You have to move only in that direction. Like that we have. Sir, I think what is mean by graph? How we are going to declare this graph? And what is mean by directed graph? And what is mean by undirected graph? It is very clear for you. Do you have any doubt in these fundamentals? Please confirm. Is it clear? Yes, please confirm everyone. Right. Now, sir, continuation for this representation of graph. We can represent, we can represent the graph. We can represent the graph in programming by using two ways. There are two ways are there to represent the graph. What is the first way is adjacency. Okay, adjacency matrix representation. Adjacency matrix representation. Second one is adjacency. Okay, adjacency. So list representation. In Java, it is very difficult to represent this, but in Python, we have inbuilt data structures are there. By using that, happily we can able to represent. What is the first one, sir? Matrix representation. Second one is what? Adjacency list representation. Don't worry, I will take one example and I will demonstrate how it will be. Okay. So now I'm taking first example for this. Maybe I will take the matrix representation. For running this program, I'm taking this so PyCharm. So here I want to take 1 second. Let me increase the font size. Right. Sir, here I'm going to take number of vertices is equal to 5. Sir, how many vertices I am going to take? 5 vertices. And I am taking a matrix list where, so 0 into number of vertices V. Okay. Number of vertices V for each I value in the range of V. Like this I am going to take. Suppose consider in this example, I am going to represent, sir, 5 vertices. That means what? So we are going to get a list with how many zeros? 5 zeros like this. Similarly, we are going to get one more list with these 5 zeros. And we are going to get one more list with 5 zeros. We are going to get one more list with 5 zeros. Like this, total how many vertices we have? 5 vertices are there, right? That's why we are going to represent by using so a list of list. This is called as adjacency matrix representation. Now we need to add the edges. Suppose consider I want to take one simple diagram like it is a 5 by 5, right? So this is nothing but I have a point is there. Let us consider 0. Okay, next and after that 1. So next and after that 2. Next and after that 3. Next and after that 4. Total 5 points are there. There is a connection between 0 to 1 and there is a connection between 0 to 4. And there is a connection between 1 to 4. Okay, there is a connection between 1 to 3 and there is a connection between 1 to 2 and there is a connection between 2 to 3 and there is a connection between 3 to 4. Like that I have a graph. How to represent this? Very simple, sir. I am taking add edge function which is going to take a list and from which vertex to which vertex there is a graph, there is a path, sir, 0 to 1. So I am going to define one special function with name add edge. Sir, it is taking a list u comma v. Can I say u is nothing but one vertex which is nothing but a source, v is nothing but another vertex which is nothing but a destination. Now I am going to take L of u comma v is equal to, I am taking 1, and L of v comma u, because it is a undirected graph. Sir, both I am going to add. Now what will happen? I am marking in the red color. Please listen. 0 to 1, there is a connection. That means, so this is 0th row, right? 0 to 1, there is a connection. And the same thing, 1 to 0 also I am going to update. Like that we have. Sir, similar to this, I want to add few more edges. What is the next edge, sir? What is the next edge that we have? 0 to 1, 0 to 4 connection is there. Sir, can I say 1 to 4 also we have a connection? Then, sir, 1 to 3 also we have a connection. Sir, then 1 to 1 to 4, 1 to 2. Okay, sir, even 1 to 2 also there is a connection. Sir, then from 2, sir, 2 to 1, anyway 1 to 2, 2 to 1 both are same, and 2 to 3 there is a connection. Can I take, sir, 2 to any other connections? No. Can I say 3 to 4 there is a connection? Like this, sir, we are going to have how many edges? 1, 2, 3, 4, 5, 6, 7 edges are there. So 7 statements I have written. Sir, I want to print this graph. How you can able to print? I am taking the function as a print graph, which is taking a list, and it is going to print a matrix style for each I in the range of the length of the list, whatever we have taken, and for j in the range of, so length of the list, whatever you are going to give, and it is going to print, so L of ij in the matrix style, and end is equal to, I am giving space. Once if the first row got completed, let us print empty line. Sir, now after adding all these things, try to print that graph and see what will happen. Sir, now I am running the program. Sir, are you seeing a matrix representation? Yes. Sir, in this you can see, this is 0th row, this is the first 0th column. So 0 to 1, there is a connection. And 1 to 0, there is a connection. Sir, 0 to 4, there is a connection. And 4 to 0, there is a connection. 4 to 0, there is a connection. Like that, you can able to check. This is nothing but how to represent the matrix by using which representation, sir? By using this matrix style, how we are going to represent. Sir, please confirm everyone is the concept of representing this graph. Is it clear for you people? Please confirm. Yes, please confirm. Right. Sir, same thing. What is another way that we have? Sir, list representation also we can take. Let us see how you can able to represent in the form of list. Linked list or list concept we can use to implement this. So I don't want to change this. I will take as it is, add edge. But here I don't want to take in the form of matrix style. Simply L of u dot append of that vertex v. And L of v dot I am appending that edge, like that I am taking. Sir, print graph. So for each I value in the range of length of list, so here itself I am going to print, so L of I comma L of I am going to print. That's all sufficient. That's all, sir. Now number of vertices is equal to 5. We are creating a list with empty elements for each I in the range of V. Now add edge of 0 comma 1, 0 comma 4, 1 comma 4. Okay. Like this I am going to add. Okay, like this I am going to add. Then print off graph as usual. Now you can see what will happen. Sir, are you seeing? It is something like adjacency list. The node, the vertex 0 is connected to which vertices? The node vertex 0 is connected with 1 and 4. and the node 1 is connected with so 0, 4, 3, 2, and the node 2 is connected with 1 and 3, and the node 3 is connected with 1 to 4. Like that, it is going to maintain a list in this format, and we are going to get a result like this. So this is the way how we can able to represent, okay, a matrix style representation and a linked list, not linked list, adjacency list representation. Are you clear with these things? Please confirm. Right. Next one, what we have. So what is the next one that we have here? So display operation. Sir, there are multiple ways are there to perform display operation in general. But especially in the graph, there are two types of display functions are there. One is nothing but breadth first. Okay, breadth first search algorithm we can use. Breadth first search algorithm. In short form, it is called as a BFS. Suppose if you have any vertex, okay, any graph is there, how you are going to apply this BFS? Very simple, sir. We have to visit, we have to visit, so each node exactly one time. That is nothing but BFS algorithm what we are going to have. Sir, what are the steps that we have? We have to start from source vertex. We have to start from source vertex. To demonstrate this, I am going to take one graph. Let us take the graph is nothing but 0th vertex. So first vertex 4 is there here, and 2 is there here, and 3 is there. Let us assume. Okay. Sir, I will take the previous program as it is. So here you can see 0 is connected with 1 and 0 is connected with 4. Sir, 1 is connected with 0, 1 is connected with 4, 1 is connected with 3, okay, and 1 is connected with 2. Like this we have. Then, so 2 is connected with 1, 2 is connected with 3. Then 3 is connected with 1, 3 is connected with 2, 3 is connected with 4. Sir, 4 is connected with 0, 1, 3. Like this, I have a graph. Now I want to implement BFS for this. What is the first step? We have to start from the source vertex. Let us consider here the source vertex is nothing but 0. Then we have to try to fetch adjacent nodes for that given node. Suppose if you start from 0, then what will happen? For 0, which nodes are adjacent, sir? 4 and 1. Okay, 4 and 1 or 1 and 4. Sir, we have to visit all these adjacent. So visit all adjacent nodes like 1 and then 4. Then what we have to do? Again, we need to find out all the remaining adjacent nodes for that adjacent nodes. We have to repeat this process. We have to repeat this process for each node. So present, okay, present in the graph. In the graph, how many nodes are there? For every node, we have to repeat this process. This is nothing but what we have. But don't worry, I will take one example program, then only you can able to understand. If you see this diagram, sir, what is the first node that we are going to take? 0. Sir, what is the adjacent nodes for 0? 1 and then 4. Sir, you have to keep the track of all the nodes. Whether these vertices are visited or not, we have to check. First, I am going to take 0. It is visited. Then adjacent nodes are 1 and then 4. Try to visit 1. Okay. Then next visit 4. Sir, next, which is adjacent to 1? Sir, 2, 3, 4. Is 2 got visited? No. Then visit that 2. Then 3 got visited? No. Visit that 3. Then 4 got visited, already visited. Leave it. Then take next node 2. Sir, which are adjacent for this 3? 3 is the adjacent, 1 is adjacent. 1 is already visited, 3 is already visited. Like that, we have to keep track of all the nodes. So this kind of approach is called as what? Breadth first search algorithm. Okay, so we have to go with so adjacent nodes. How many adjacent nodes are there? We have to find out. We need to take. Okay, sir, everyone feeling comfortable up to this whatever I covered, please confirm. Right. Sir, we need to see with the help of example how we can able to implement this. Very simple, sir. To apply this, I'm going to take one predefined class is there. Okay, one predefined module is there called collections. From collections, I'm going to import DQ. Add edge list comma u comma v. Sir, I'm taking this same program as it is. Now I want to implement which algorithm? Sir, BFS, breadth first search, which is going to take a list and a source. Sir, first step is what I told, we have to keep the track of all the nodes. I'm taking a visited array with all the elements as a false. Sir, how many elements should be there? How many vertices are there? With those many values, we are going to create one visited array. Then I'm keeping a queue here, DQ. I'm going to create a queue here. Sir, after this, in this queue, okay, in this queue, I'm going to append that source, sir. Which one you need to visit first? We have to append. Sir, better I will take the color white and I will explain. Initially, we have a queue is there. In that from which node we are going to start? 0. I added that 0. Then please make sure visited of that source will become true, sir. Then while queue, sir, is the queue is not empty? Yes. Then so source is equal to q dot pop left. There is one special method is there called pop left. It is going to pop the element called 0. Now what is your requirement? Sir, you need to print that 0. You have to print that source comma end is equal to empty. Now identify which are adjacent for that 0. How you can get for each I value in the list of a source, adjacent nodes will be there. Now I am going to check is visited of that particular element is equal to false. If it is not visited, try to append that into the queue and make it as a visited. Like this we are going to take. So if you repeat this process, what will happen? All the elements are going to be visited. That's all, sir. This is nothing but BFS what we have. Now, if you want to run this, what we have to do? After printing the graph, I am printing one empty line and we are going to call, sir, BFS. What is the method name that I have taken? BFS of that list comma, sir, starting vertex. Like this I am taking. Now run this program and see what output we are getting. Sir, are you seeing 0? Okay, 0, 1, 4, 3, 0, 1, 4, 2, 3. Sir, either 3, 2 or 3, 2, 3, no problem. In which order the elements will be added in the queue, in that order it is going to take. This is nothing but BFS algorithm what we have related to the graph. Sir, everyone feeling comfortable up to this, please confirm. Sir, clear up to this? Right. Right. Sir, same thing. I want to go for DFS. Sir, what is mean by DFS? It is same like BFS, sir. Depth first, depth first search. DFS. Depth first search. How we are going to apply this? Very simple. Sir, we have to visit each node exactly once in this case also. And we have to start from source vertex. We are going to start from source vertex and we have to try to fetch its first adjacent node. First adjacent node we have to take and visit, sir, till the depth by using recursion. We have to see till depth, sir. Okay. Then we have to repeat this process for each node present in the graph. Sir, in the BFS, we used stack, sorry, queue, but here we have to use a stack, sir. Listen, I'm going to take another color and I will demonstrate for the same graph. See, here also we are going to make the visited array like 0, 1, 2, 3, 4. Sir, first we will start from 0. Visit that, print that. And which are adjacent for 0, 1 and then 4. So try to keep the track of 1. Sir, 1. Visit that. And which is adjacent for 1? Sir, don't go for another adjacent. We have to go for in depth. So which are adjacent for 1? Sir, 2, 3, 4. Okay. Then immediately visit 2. Then which are adjacent for 2? Sir, 3 and then 1. 1 is already visited, go for 3. Then which are adjacent for 3? Sir, 2, 4, 1. 1 is already visited, 2 is already visited. So go for 4. Like this, sir, depth wise. Once if you start, we will go with depth like this. But in the case of BFS, what we are going to do, we will take a node, we will find out all the adjacent. Then again, this adjacent we are going to expand. Like this, we are going to get. But in the case of this depth first search, what we are going to do, we will start from this and we will keep on moving to the till depth. Then only we will come back and then we will go for next iteration. Like this, we are going to get. Sir, please confirm, is the theoretical concept related to this depth first search? Is it clear for you people, guys? Please confirm, friends. Right, sir. Right. Now, sir, let us implement the same program for this. I implemented already BFS. Sir, same thing I am going to take DFS. I am taking a list and then, sir, source vertex. See, here we have to implement the recursion. That's why I am taking visited array with all the elements as a false with length of the list. Then I'm going to call this DFS util function by taking the L source and then visited. So we have to implement the term. So DFS utility functionality. Sir, where I'm going to take list and then source vertex and then we are going to take the visited array. Sir, after this, we are printing that source vertex and please make sure end is equal to empty. After that, make that node visited of source will become true. Sir, is my voice is clear? Please confirm. Sir, is my voice is clear? Please confirm. Right. Sir, is my voice is clear? Priyanka. Yes, right. So DFS util visited. mm, Maybe for this graph, we are getting same output in both cases. Maybe 0 and then 1. So one expansion, it should come maybe 4, 3, 4, again 3, like this. Okay, we will change the graph and we will try to check. So what I'm going to do here is I will take a graph with 4 vertices. Okay, so there is a connection between 0 to 1. So then there is a connection between 0 to 2, and there is a connection between 1 to 2, and there is a connection between 1 to 3, and there is a connection between 2 to 3. Like this I am going to take. Now we will check. In this case also we are getting for both BFS and DFS same answer. Mm, Correct only, but I don't know why it is not coming. Okay, I will try to change the graph again and we will cross check. We will change another graph. Okay, so what is the next graph I am taking? Because sometimes these graphs are going to be take the equivalent values, that's why. So I will take with the 6 vertices. Okay, so here I am going to take, there is a connection between 0 to 1, so 0 to 2, and then I am taking, so 0 to 5 there is a vertex. So next I am taking 1 to 3, there is a vertex. Sir, 2 to 4 there is a vertex. Okay, next add edge of, for the list I am taking 3 to 5 there is a edge, then add edge of I am taking a list. So there is a connection between 4 to 5. Like this I am going to take. Let us consider. Yeah, you can see now there is a change. This is nothing but BFS, what we are going to get for this particular tree. And this is nothing but a DFS. Is there any change or not? Yes. So you can write the diagram for this graph and you can trace out. Sir, are you clear with this BFS and DFS algorithm, how it is going to work? Please confirm. Everyone, please confirm. Clear up to this? Right. So that's all about the graph data structure what we have. In depth, some still advanced level concepts are there. Those are not required as of now. Okay. Sir, tomorrow I will continue. Tomorrow we are going to see that priority queue, AVL trees, and different kinds of analysis for these algorithms, and I will close. Okay. Right, sir. Thank you. Tomorrow we will meet for the continuation as usual at 8 o'clock. Thank you.